Today, we're going to break down how a massive, brand new piece of public infrastructure can just catastrophically fail. We're not talking about some ancient bridge or a crumbling old dam. No, this is about a state-of-the-art highway wall that was supposed to last for decades. We're going to peel back all the layers of this disaster to figure out how a brand new highway can literally vanish, and how the investigation revealed this was no accident at all.
So, picture this. December 5th, 2025, near Kottiyam in Kerala. A huge retaining wall holding up the new NH66 highway doesn't just crack or crumble, it completely disintegrates. A section almost half a football field long just gone, in less than a minute. It was this sudden, violent, and honestly shocking failure of something that was meant to be a symbol of progress.
So what exactly happened here? Well, a newly built wall, designed to hold back tons and tons of soil, just collapsed. It took the service road right next to it down with it, trapping cars and, the most terrifying part, a school bus. Miraculously, no one was killed. But it brings up this huge question that's really the focus of our explainer. How on earth could this happen? As we're about to see, the investigation showed this wasn't just a failure of concrete and steel, but a disaster that was both predicted and, entirely preventable.
Okay, so to understand how it all went so wrong, we have to look at the moments just before the collapse. What investigators found was that while the end seemed instantaneous, it was really just the final step in a very clear progressive failure.
Now, what's so fascinating here is that the disaster basically announced it was coming. For weeks, there were warning signs. You had cracks showing up in the road, the wall panels themselves started to bulge outwards. Then, on the day it collapsed, the soaked ground underneath just lost all its strength and things sped up fast. The final act was the internal reinforcements just pulling out of the soil, kind of like pulling threads out of wet paper. And then the whole thing just came down. The key takeaway here is the wall was screaming for help long before it gave up.
So why did it fail? I want you to think of it like a stack of Swiss cheese, where every hole is a different mistake. For a disaster like this to happen, all those holes have to line up perfectly. And the very first and probably the biggest hole in this story was the ground the wall was built on.
Before we dig in, we need to get one key engineering term down: bearing capacity. It's actually pretty simple. Imagine you're pressing down on a sponge. At some point, you press too hard, and the sponge just squishes, right? It can't support any more weight. Bearing capacity is exactly the same idea, but for soil. It's the absolute maximum pressure the ground can handle before it gives way.
And this table just lays out the first catastrophic error perfectly. The designers assumed they were building on solid, stable ground that could handle a pressure of 150 kilopascals. But the reality on site? They were building on what was basically reclaimed swamp, soft, wet, alluvial soil with a real bearing capacity of only 30 to 50 kilopascals. I mean, the ground was, at best, a third as strong as the blueprints claimed. The foundation was doomed from day one.
Okay, so the foundation was fundamentally unsafe. We've got that. But in a project this big, there are supposed to be multiple layers of safety, right? So, was this weak ground the only problem, or did some other holes in that Swiss cheese line up too? Let's move to the next layer and see. All right, the second major failure was this huge, invisible force of water. The wall wasn't just trying to hold back soil, it was trying to act like a dam against a rising tide of groundwater that had absolutely nowhere to go.
The trigger was just a ton of rain. In the 4 days right before the collapse, the area got soaked with 120 millimeters of rain. That is a huge amount of water, and it all had to go somewhere.
And here's the problem. Because the highway construction had blocked all the natural drainage paths, that rainwater couldn't escape. It just soaked into the ground, and the water table, that's the level of groundwater, shot up by 1.2 meters. It effectively trapped a massive reservoir of water right behind the retaining wall. And the effect of that was, well, it was devastating. This trapped water exerted this immense pressure. It's called hydrostatic pressure. But basically, it was the sheer weight of the water pushing outwards. It acted like a giant hydraulic jack. It added a staggering 40% more force than the wall was ever designed to handle. It was the knockout blow to a structure that was already standing on shaky ground.
So we have weak ground, we have immense water pressure, but the third layer of failure shows us that the wall itself was the completely wrong design for this location in the first place. This wasn't just a flawed structure, it was a blueprint for disaster.
So here's something that's really wild. The engineering report found that the contractors used a standard one-size-fits-all design template, a design made for projects in dry regions like Gujarat. That design assumes you have stable soil and very little water, and they just copied and pasted it without any changes, into the waterlogged, soft soil reality of coastal Kerala. It's like using the blueprints for a desert house to try and build a boat. It was never going to work.
And if you look at the specifics, it gets even worse. The foundation, over a third too narrow. The steel strips that are supposed to anchor the wall into the dirt, up to 40% too short. The material they used as backfill was all wrong, and the drainage layer that's supposed to relieve water pressure was only half as thick as it needed to be. Every single one of these choices made a terrible situation even worse.
And that brings us to the final, and frankly, the most troubling layer of this whole failure. This wasn't just about soil, water, and bad design. It was about a complete and total breakdown of the human systems, of oversight, of quality control, and of learning from your mistakes.
This quote from the official report is it's absolutely shocking. This exact same type of collapse had already happened just 6 months earlier at another spot called Kottiyam, on the very same highway project. The engineers, the consultants, the authorities, they all knew this design was failing in these conditions, and yet they did nothing to change course.
A huge reason they didn't see the risks was because the site investigation was just pathetic. This chart shows it perfectly. For this kind of ground, you're supposed to drill test holes every 100 meters to see what you're dealing with. They drilled them every 500 meters. They did only a fifth of the work required to actually understand the ground they were building on.
I mean, this list of failures is just staggering. They used the same consultant from the previous collapse. They installed 0 instruments to check if the wall was moving. They skipped more than half of the required material tests, submitted fake reports, and put schedule and cost cutting way ahead of safety. This wasn't just one mistake, it was a total systemic breakdown.
So, after all that, what are the lessons here? What do we take away from this completely preventable disaster? The final report really pieces it all together.
This chart really breaks it down for us. See, the collapse wasn't because of any one single thing. It was a deadly combination. 40% of the blame goes to that incredibly weak foundation, 30% to the insane water pressure, and the final 30% to that whole cascade of bad design choices and systemic human error. All of those holes in the Swiss cheese had to line up perfectly for this to happen.
And this is the final damning conclusion from the engineers who investigated the whole mess. The most important thing to understand is that this wasn't some act of God or a surprise geological problem nobody could have seen coming. No, it was a quality control catastrophe. The knowledge, the standards, the technology to build this wall safely, it all exists. The failure was entirely in applying it, enforcing it, and in an organizational culture that just refused to learn from its own recent mistakes.
Which leaves us with one final thought. The investigation proved that not only was this collapse preventable, it was predictable. A nearly identical failure had already happened just months before. The warning signs were everywhere. And that forces us to ask a really tough question. When a disaster is this predictable, can we really even call it an accident?